checklists to understand and experimentally determine the value of the Young Modulus of the material, determine the Young Modulus of the metal wear, to analyze the experimental data, identify methods to improve the results.
So during these 3 lessons, you will be developing many skills to prepare you for the exam, for the practical exam that you will take at the end of next year. So you will do the kind of skills, making accurate measurements, evaluating the experiment. I think that's probably the most important one. How can this experiment be improved? And then drawing graphs. So there are the 3 lessons. In the 3rd lesson, we will be drawing graphs and analysing the gradient. Okay, so those are very, very quite difficult skills, but those are very important skills for us to have a try at today.
So we will work as following. Here is schedule for lesson 1. Preparation for the experiment. Define and use the terms stress, strain, and the Young Modulus. Describe an experiment to determine the Young Modulus. Subjective notes. Schedule for lesson 2. Making measurements. Instructions. Performing laboratory work. Completing the table, and reflection. Schedule for lesson 3. Drawing high quality graphs, determination of Young Modulus, using graphical method, evaluation.
So in the 1st lesson we'll show you what to do, in the 2nd lesson you'll do it, on the 3rd lesson you'll analyse the results. Okay?
During our lessons will we use the following terms: stretch, sozlu, tension, sozlu, stress, herneu, жіктеме, modulus, modul, stiffness, katılık, properties, қасиеттер, behavior, өзіне өзі ұстау, material system, материал жүйе, cross-sectional area, көлденең қима ауданы, original length, бастапқы ұзындық, extension, sozlu.
Any questions? No. Okay. I'm a little bit worried about this. You have the same word for 2 different things in English.
3 words.
3 words.
The last.
Oh my goodness. Okay, good. Can I just explain, or does anybody else want to explain? Okay. When I pull something like this, I stretch the spring. So or we say the spring is being stretched. Okay. It now has a force of tension within it. Okay, and actually there are 2 forces, this hand and this hand. If there was only one force, then the spring would move, would accelerate. So it needs those 2. There's 2 forces, and that is tension. Extension is the amount, the length that it has stretched from its original length. This is the original length, and this, the increase in length, is the extension. In English, we sometimes talk about the amount of stretch, but really, scientifically, in physics, we should say the extension. Okay? Thank you. So let's look at some of the definitions first of all. The Young Modulus, just put your hand up please, or if that's a new term for you, if you've never heard it before. So you've all heard the Young Modulus. Okay, so there's nothing complicated as you know about the Young Modulus. It's just a number. It's just a number. And that number tells us something about the stiffness of a material. You can see that this spring is not stiff. Look, compared with this, it's very stiff. Okay? And this is also very stiff. The copper, can you see, just look at the equipment in front of you, can you see a little piece of wire like this in front of you there? You're going to measure how stiff that piece of wire is. Okay? That's what we're doing today when we measure the Young Modulus. Okay? So very stiff material will have a high Young Modulus. For example, steel, look at the number here, 20.59 times 10 to the 4 megapascals. Pascals is the same unit as pressure. Good, well done. And you'll see why when you look at the equation. Copper is less stiff, about half of the stiffness, you could say. Okay? And can you see why we've drawn in here that the blue line is more steep? Let's have a look. Look at the axes here we've got, which you can't see very clearly, unfortunately, on this particular lamp. The stress is here, and the strain is here. We'll talk more about those in just a second. Okay. Stiffness. A stiff material is difficult to stretch. For example, steel, concrete, and glass. So that's this guy here, the blue line. It's difficult to stretch, so it's going to be up here. If it's easy to stretch, it's going to be down here, down this way here. So, for a very stiff material, a large force or a large stress, what I'd like you to think about, please, is force and stress kind of belong in the same box, almost the same meaning. In the same way with Newton's second law of motion, force and acceleration kind of go together. Then down here we have strain. I want you to think about that as being the amount of stretch or the extension per unit length. And we'll talk about more of those in just a second. So a stiff material, okay, something that does not easily stretch, okay, is going to be up this way. Something that does easily stretch, so a piece of rubber, for example, very easy to stretch a piece of rubber, that would be down this way here. Any questions? Okay. Stress and strain, just to remind you, okay, stress is the amount of force shared by the area. Okay? That's why it looks very much like pressure, doesn't it? The equation for pressure. So that's why we've got pascals. Okay? So it's a force per unit, and we use the sigma for that. So here's our sample. You could think about the sample of wire that you have here, the length of wire that you're using, as being this fella here, this guy. Okay? That's the original length that you're going to stretch. You're going to apply a force on both sides. You're going to watch it stretching. You're going to measure the cross-sectional area. Just think about, look at the cross-sectional area of this. It's very, very small. How are you going to measure the cross-sectional area of that? And then from that information, we can work out the stress, the force per unit area, and the strain, which is the extension divided by the original length. It's okay? Moving on. So the Young Modulus, the stiffness of the material, is the stress divided by the strain. Sigma over epsilon. Units of pascals. Personally, as a student and as a teacher, I find this is the most useful equation to learn, if I'm going to learn any of those equations at all. Because this has all of the elements in. It's got F, it's got A, it's got extension, it's got length. It's all there. Okay? And that's equal to E, the Young Modulus. It's okay? Okay. So how will you measure it? Very, very simply. Just a very quick summary. We'll go into more detail in just a second. You're going to measure the cross-sectional area. Now the cross-sectional area is this area here. Do that by measuring the diameter. And you know from your mathematics how to then calculate the area if you know the diameter. Measure the original length, which we're calling L0. Then we need to apply a force. We actually need to apply two forces to stretch it. Okay. And then we're going to measure the extension, how much it stretches. We're going to do that once, and then we're going to do it again and again and again. We're going to stretch it more like this. So your copper will go stretch, 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 stretch. Okay? And each time you apply a force, you're going to measure the extension. And then you've talked about Hooke's law. If you wanted to measure the stiffness of this spring, that would be, I would call that K, F equals Kx. Yes? And how would you do that? You'd apply a force, apply a force, apply a force, apply a force, and then draw a graph of the force against the extension. Yeah? And you'd have a straight line. If you obeyed Hooke's law, you'd have a straight line. And from the gradient of that straight line, you could work out the stiffness of the spring. Now listen to the words I'm using. The stiffness of the spring for Hooke's law, the stiffness of the material, copper, for the Young Modulus. And that's the very important difference. Hooke's law tells you about the stiffness of the one spring, or the long spring, or the short spring, or the fat spring. The spring, or the system. The Young Modulus tells us the stiffness of the material, copper, steel, concrete, glass, the material. Very important point. So, we're going to measure the extension, and then we're going to apply more forces, boom, 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 and then plot a graph, and then we're going to measure the gradient of the line. Okay, so that's what you'll be doing. Today, you will, in the second lesson today, you'll be doing this measurement. In the third lesson on Wednesday, you will be measuring the gradient of the line. Here's the equipment sitting in front of you, pretty much. So I'll just point out some very important points here, first of all. Where is L0? Where is the original length of the wire? Well, we could say the original length of the wire goes from here all the way down through to here. But that's actually quite difficult to measure the length of. So it's because you can't get your ruler to bend around the wheel. Okay? So what we do is we put this little marker on here. In fact, you have two green pieces of paper. Can you see the two big green pieces look like this? Okay, so you have two of those. You put one here. In fact, I think that's a little bit too far up. I'd like to have it a bit further down here. And then you have another one here. And then the distance between those two green pieces of paper, that distance then becomes your length of wire, L0. That's your sample of wire. And now you're going to apply the force and watch that stretch. Okay? So that's the purpose of that particular piece there. The tray here you see on the floor, that's to catch the weights if the masses, if it breaks, if the copper breaks. If the copper breaks, is that dangerous? It is quite dangerous. It's quite dangerous. If you take these masses, all of this, you know that if you stretch a spring, you put energy into the spring. You give it energy. Yeah? And that energy, that potential energy stored in there can be converted into kinetic energy. Well, imagine how much potential energy, if you put all of that onto your piece of copper wire, can you imagine how much energy is being stored in there? If the wire then breaks here, all of that potential energy is now converted into kinetic energy, and this will fly very, very quickly. If your face is in the way, then it will cut your skin, or even cut your eyes. So you must wear these. If you're wearing glasses now, it's fine. You don't need two pairs of glasses. Okay, that would be too much. But you must wear one of these if you're working around the copper when it's in tension. Any questions about that? So you see, it's quite simple, really. We're going to apply the forces here, stretch, and this will, okay, and you're going to measure the length. Okay, good. So, a little bit of revision about the theory. Any questions about the theory? Because we're going to give you some tests to do now. Question?
How we can find force of...
Good question. Excellent question. Because we need force, we need area, we need extension, and we need length, don't we, to find the Young Modulus?
Yeah, we can find strain, but we can...
How to find the force?
Yeah.
Any ideas? Let's go back. Could we go back to mg. What's the m?
Mass.
That's the mass. So each time we apply another mass onto our hanger, 100 grams, that would be how many newtons? How many newtons would one of these guys be? This is 100 grams. 1 newton. 1 newton. Okay? So each time we apply one of these, then you've got some small ones as well, so that'll be half a newton. It's okay? Okay, so that's F.
Hold on.
Умножаешь на снизь квадрат и делишь на 4.
It's okay? Good. Any questions are good questions. Seriously, because in my experience as a teacher, if one person asks a question, it means there are 6 other people in the room who didn't ask the question. Okay? So good, well done. Activity now.
Activity for you. You have to photograph of stress and strain. Correctly fill in the table. And to show your answer, raise the card of the corresponding ball. You have 10 seconds.
Maybe 12. So which one is steel? Which one of those graphs is steel?
First.
You've got the cards in front of you. You've got the very expensive cards. Use those. What colour? Steel. Okay. These 2 tables haven't answered.
Answer for A.
Okay, good.
Answer for B.
B, we've got a yellow.
B.
B, just hold your card up. Okay. We've got yellows and blues. Mostly yellows. We can discuss this in a moment. Okay, good.
Answer for C.
See, we've got the yellows and blues again. Good.
And answer for D. Okay.
We're happy with that? Good.
Let's check your answer.
So if you had blue, so this is just our opinion. This is just our opinion. You know, we are excellent, but we're not always right. So, what if you had blue for rubber or yellow for skin? Why? What were you thinking? What were your ideas?
Rubber is like elastic.
Yes.
Skin is like it may like break, but it's
Nice thinking. So rubber is very stretchy.
yes.
Yeah, so it's very elastic, and skin, although it can move, it would tear. Yeah, it's quite stiff.
And also we can guess what kinds of rubber. There are lots of kinds of this. For
Excellent.
example, some kinds of more strange and
Yes.
has
That's nice thinking.
but
So
skins we also got one.
say that again.
Same skin.
Same skin.
Yes.
Do you agree? I disagree with the skin. My experience is that the
No,
skin.
there was hand.
Oh, on the hand. You're right. Yes, it was the surface of the hand. Which surface? The back surface or the front surface? But there is a difference, isn't there? There is. It's amazing. So good. For A level, and I think for your SAT as well, these are the kind of questions they're going to ask you to think about. So they say to use your common sense and your experience. Okay. So really good work. Well done.
Exercise 2. 4 wires A, B, C, and D have diameters, lengths, and are stretched by forces as shown. All the wires are made of the same material. Which wire has the smallest extension? You have 10 minutes. 10 seconds.
Hold it. 10 minutes.
10 seconds.
Hold your colour. Don't shout out. Hold up your colour card.
Only one answer. Answer, please. Your answer.
Have a green. Have a blue. Is that clean? All hands. Is that
Your
blue?
answer.
Okay.
I didn't understand shit.
Smallest extension.
Which one of these 4 objects has the smallest extension?
Let's answer. Your answer. Женя, your answer. Which color?
got the which one has got the longest extension? See? Good, good. So it's long and thin. That hopefully that's what's going to happen to your copper wire. That's why we're using it. Okay, so four times maybe equal to 10 centimeters. So I think okay. So I think we can move it down. That's good. That's good.
Не может измениться, потому что он изменится 200. Если 200 это повышено. Может, не будет измениться.
Тут функционал такой.
Results there. Good, good.
Нет, диаметр.
Yeah. It didn't want to stretch, did it? Very small, very small.
Давай 200 сразу. 200, 400.
Okay, good.
А что, и подальше?
Certainly, developing the skills.
посмотрим.
That's important.
Еще можно.
Very small change.
Yes.
It is very small change. Very good. You're developing the skills, that's important. Guys, how's it going?
So, we finished.
You finished?
Там 10 тысяч? Да, да, да. У тебя сразу уже нагрузка выйти. Ты видишь, почему еще?
I don't think you're going to have time to do it now. We're planning to do it next lesson. Let's have a look at your results here, though. Stress levels. Ooh. If you have time to do them now, it would be good. Your results look interesting. It's pretty impressive, actually. It's good that you managed to get that.
How we need to use it like this or?
Well, actually, as a student, you need to decide.
А у нас самостоятельно что добавлять?
It's 9 across here. So we've got about 4, say 5. One here and here we've got about 14. So I would, if it was me, I would say that 14 is going to fit on the 8 level. So line here first. So add this one, young modulus here. Add another one. Add them one at a time. Okay, this is what I would expect you to do. I would expect you to add your masses, okay, and measure the length, and stretch it, okay, and then take the weights up again, one at a time. Take the weight off, and then measure this length here, as it gets smaller and smaller. Yeah. Okay, and then for this one, add the masses again. Watch your stretch. Okay, so you added the masses.
In lesson 1 and lesson 2, we learned how to measure the Young Modulus. And this lesson 3, we learn, recall how to grow a good graph at a level, and we learn how to use graph to determine Young Modulus and self-assessment, our new skills.
At the end of today's lesson, we will ask you to assess yourself, to decide how well you have completed these skills. If you remember, last lesson we did say that these 3 lessons were about skills development. Okay, so we want you to think about the skills, and we'll give you this worksheet to complete at the end of today's lesson. So let me first of all start today by saying thank you. So you're going to draw a graph today. Okay, maybe you've got enough data from your previous lessons to draw a good graph. If you don't, then we will give you some data, and then you can use this data to draw a good graph. Now, here's an example of a graph that I found on the internet. Just have a look this way, please, ladies and gentlemen. This way, please. Thank you. So just have a look, please. On here, we've got stress. We've got the axes have been labelled: stress and strain. We've got percentage down here, we've got megapascals up here. You need to have that on your graph. Not because we say so, but because that's what the examiner will be looking for. You are very intelligent students. You will get a very high grade. Wouldn't it be very sad if you lost 1 mark or 2 marks from your exam because you didn't write these in here? Okay? In grade 7 you can do this. So make sure you do it. Look at the crosses here. We're not seeing this. Okay, we're not seeing anything written like this. Okay, this would be wrong. We need to see a nice, neat cross. Small, sharp point. Make sense? Have a quick look at this graph here as well. There are actually 2 on here. See, there's a curve and there's a curve. We're not interested in the curve. We're interested in the straight line part, where that's where we're going to measure Young's modulus. That's where the material, the copper, is elastic. Okay, so going back to its original position. Everybody needs to be looking this way, please. Everybody looking this way. Thank you. Professional graph. All right, I expect you to be drawing a graph as professionally as this. Not because we're excited about it, although we are, but because we want you to see you doing really well. Very quickly, draw your graph with a sharp, pointed pencil. Okay, I don't see a big, clumpy pencil. Okay, nice thing. Why? Because it's more accurate. Okay? The size of the graph must occupy more than half of the paper. Look at this lovely graph here. Can you see? It's using up more than half of the paper. It's not a tiny little graph down here. The axes must be labelled. Each point on your graph should be a small cross, no blobs. Okay, we don't want any of that. It's a nice small cross. Here's another example here. Nice small crosses drawn on here. Okay, nice range. How to determine the gradients. I think you know how to do the gradient. Let's talk about that very quickly. Imagine that you've drawn something like this. Okay, and you've got to choose a point here and a point here, and
Now, which
draw a
point
nice
are you going to
large.
choose? That's a nice point.
To the side, can you see
And
the
don't
size of
use a
triangle
point
here?
that you use to
Like,
draw the graph
it's
with.
not a tiny
Use a
triangle.
point like
Some people say- some
this one
students
here,
say to us,
for example,
okay, if I draw a triangle
because
here,
that's where the cross of the graph paper meets the line. So that's a nice one to use. That's a good point to use there as well. Here's another good point to use as well. Okay, so you can use those to draw your triangle with. Looks very good.
What was your answer? There's the minus something. So what was your stress? What was the change in? That would be 10 to the minus 8. How big is the stress? The delta, the change in stress.
Давай по-другому способу. Просто у меня тут встречается. И сколько? Это
Seems about right. So we should be getting stress over strain. So roughly we've got 7 times 10 to the minus 7. Sorry, 7 times 10 to the 7. Divided by 10 to the minus 3. So I think that should be about 10 to the power of 10. Which is, that's that, but 10 to the power of 10. What did you do wrong?
We divided in.
Okay, you're not sure? Have a look through. The results in your table is looking good. 18 Is this from my data? Okay, so that's right on 18. 18 that's good. It's very useful for you during the exam to write for you to write on here. What's the meaning? So you can see how it's important to get that right. If you get that right, this is as it is. 0.78. Okay, so this divided by this. Well, I'm looking at that. 70 divided by 0.78. It's about the reason I'm doing that is to get that right. So the answer should be 100. The answer is 10 to the power of 10. No. 10 to the power of 11. So you know you got right. Okay, whatever your number is, you're in the right ballpark. Now we need to finish soon. Do you think they need more time in this lesson? more time next lesson to finish this? No? Yes? I feel like you do. I feel like you could do a little bit more time. So we'll do a little bit more on this next lesson. Yes, but I think we should do the ending anyway. So let's just move on. Yes, so it's 9 times 10 to the 8, 10. 9 times 10 to 10. It's not bad. The Young Modulus is a range, it's not an exact number. So your science and your methods is good, very good.
Надо якийсь оперативний план. Uzunluk kolay almasın şey.
Okay, I need you to stop what you're doing, please, for 2 minutes. Okay, sorry to stop you. We will do more of this next lesson. Okay, we can see that you need a little bit more time, so we will give you time next lesson. So we're just going to ask you to stop as we finish the lesson now. Which lesson do you go to next? Physics? Physics? Oh, you have a good lesson. That's the next lesson. Okay, so we're just going to finish this lesson here by just asking you to complete the sheet that we've given you there. Which skill, of these skills here, give yourself a grade from 1 to 10 and how well you think you've done. So, will you all listening please? Leave your graph alone. Leave your graph alone. How's your listening skill? Come on. Give yourself a mark on the sheet that you have there in front of you. How are you doing following written instructions? You've given you lots of instructions. Okay, and I'm thinking that most of you would be a great kid. We will do more of this next lesson. Making accurate measurement, okay? We can see that you need to do more time, so we will give you time. It does not have one of those. So we're just going to ask you to take 1 minute as we finish the lesson now. Which lesson do you go to next? We're going to think about the skills. Physics? Physics? Oh, you have a good lesson. That's the next lesson. Okay, so we're just going to finish this lesson here by just asking you to complete the sheet that we've given you there. Which skill, of these skills here, give yourself a grade from 1 to 10 and how well you think you've done. So, will you all listening please? Leave your graph alone. Leave your graph alone. How's your listening skill? Come on. Give yourself a mark on the sheet that you have there in front of you. How are you doing following written instructions? You've given you lots of instructions. Okay, and I'm thinking that most of you would be a grade 10 for that. Making accurate measurements. Okay, could you fill in your sheets, please? Is there anybody who does not have one of those sheets? Okay. Take 1 minute to fill that sheet in, please. We're going to think about the skills that you've been learning over the past 3 lessons. Just 30 seconds, have a look at that sheet, please. your sheet then, just before we finish very quickly, is there any skill on there that you think that we need to teach you a little bit more about? Have you got any low numbers? Do you have any low numbers there? Where? Which one? Just tell us. Which one? Drawing the graph. Okay. I think that one or two people were still drawing the line of best fit, getting that bit wrong. Is that right? Okay, so we can work on that one a little bit too. Anything else? Does anybody want to say anything else?
Anybody? So, what did you learn? What did you enjoy? What could improve? Anybody?
I have learned that first of all we have to read the instructions and then to make them, because I have made mistakes because I didn't first of all read what I was given, and I have drawn wrong graph.
Right. That is amazing. Thank you for saying that. So many students that go into the examination, paper 3 exam, do exactly that. They think, oh, we must get on and do the work, and they forget to read, and then they lose marks. So excellent, thank you for mentioning that.
I've learned new details around the graph. For example, a process, we should draw a process, not a dot graph. And I'm just on drawing a card from these new criteria because I have other things about it, other thoughts about it, and I should change my skills to follow these criteria. And I could improve the skill drawing graph.
Drawing the graph. Okay. Thank you. Anybody else before we finish?
Mark your reaction.
Okay. Good. So it's time for you to take a break. Okay. Thank you very much. We'll see you after the break.
Thank you.